Please subscribe and don't forget to press the bell icon to get notified whenever we upload a new video.
Hello and welcome to this special edition of Young Turks. We come to you from the sidelines of the MTech Awards 2018. I'm in conversation with two entrepreneurs that have a certain degree of commonality in the work that they are doing. One of them is using light to transmit network data, and the other one's actually experimenting with using the human body to do so. So let's get into a conversation with Deepak and Shreyas. Thanks a lot for joining us on this program. Pleasure to have both of you here. Deepak, if I can start with you. Velmenni, the company that you started back in 2014, experimenting with using LiFi or light to transmit data, much on the lines of how Wi-Fi uses radio waves. So talk to us a little bit about what sparked your interest in this area and what you've been able to do with Velmenni over the last 4 years.
How I started was I had a keen interest in wireless technologies. I'm an amateur radio operator, so I have been transmitting data to space and other, anywhere in the world utilizing the radio frequency. I have my own base station. Came across LiFi, which is used to be known as visible light communication in the past. So they were utilizing light to send data, and it was quite fascinating for me. So I started doing research, and I thought, okay, this is interesting. And in the startup, we have actually built up the product and now doing proof of concepts globally to take this to masses.
Tell us about the consumer application that's available now with LiFi, the breakthroughs that you've been able to achieve.
So at the moment, we created a solution which can be deployed with generic LED lamps, and it's a retrofit solution. So in a simple scenario, anywhere in office or homes, we can access internet through light.
So you're saying that I can use a retrofit device that you have, plug it into an LED light or lights in my home, and then use data through that?
Exactly, that's what we have done now. It's pretty secure and very high speed.
How does it compare? Can you give us a comparison with Wi-Fi?
If we do the comparison, eventually we can get the maximum speeds up to 1 gigabit per second with the light, which is like the fastest Wi-Fi router will give you the similar, but it's not commonly available. It's industry specific.
So you've piqued our interest, Deepak, but I'm going to move to your co-panelist here, Shreyas Sen, who works at Purdue University, and as part of your professorship there and your work there, you stumbled upon the idea of using the human body as a networking agent for devices to speak with each other. Tell us about how this happened.
During my PhD at Georgia Tech, I was working on wireless technologies, and like Deepak, I used to be a wireless enthusiast and try to reduce the energy of wireless communication. Then I went to Intel Labs, and I was one of the people working on the USB-C type prototype. And we saw during that development how wireline technology can be very energy efficient. But when you have to communicate between one place to another, you cannot do that because you have to use the airwaves. When I moved to Purdue, I always wanted to combine my love for biology and engineering. And I started thinking, I was very interested in the wearables and implantable spaces. And today's state of the art is these wearables connect by encoding data on electromagnetic spectrum, which is the wireless technology. So the signal comes out of your body and goes to the other device. So we were thinking, how can we make it better? And we stumbled upon the fact that body, thanks to the high water content, is very conductive.
Yes.
So if all the devices are on the body or in the body, why not connect them with the body itself, which will provide you this wire-like bandwidth and hence a lot of lower energy. The chip I'll show you today is 100x lower energy than today's wireless body area network.
This is actually a throwback to, 6th or 7th grade basic physics and biology in that sense, right? But just that a lot of factors have now come together, Shreyas, at this point of time in our evolution, where we are actually able to make these connections. What could be the eventual use case for this?
So first of all, thanks to over 5 decades of continued miniaturization following Moore's law, so everything is becoming smaller. Back in the 60s, a computer used to be a room-sized. Right. Today, computer is smartwatch-sized, right? Later, it could be like a pill-sized, which you can have it, and it would image your digestive tract. There is already a company called PillCam, which is doing it. Now, these smart chips will be all around us, as well as on us and in us. And because of scaling, the energy efficiency have become so small that with tiny amounts of battery size, we can still power these devices.
So I'm clearly fascinated, but I'm going to ask you, Deepak, actually to pose a question to Shreyas. What part of the work that he's working on do you find fascinating, and do you have a question for him?
You mentioned that human body, we are utilizing it as a conductor, but ideally the human body is a bad conductor of electricity. So, how can you achieve higher, if required, higher data transfer rate for the communication?
If you're comparing with copper, yes, it's not as good conductive. But if you're comparing with the airwaves,
Okay.
Because of the high water content, it is actually very conductive.
Okay.
And the non-conductive part is your skin, which acts as a capacitance.
Right.
And this technology is called subcutaneous transport, because
Okay.
what you do is from your smartwatch, you use the skin as a capacitance and couple it inside. And once you couple it inside, the tissue layers are very conductive.
So we were speaking earlier, Deepak, and you mentioned about standardization of LiFi, much in the same way that Wi-Fi was standardized a few years ago. So tell us about progress in that area, and tell us about the work that you and some of the other startups that are part of the consortium that's now working towards the standardization, the work that you all are doing vis-a-vis the work that's happening in the labs of the Qualcomms and the Samsungs and the Apples of the world. Do you feel like the underdog at all?
The companies like Samsung, Apple, and even Qualcomm's, they are actually evaluating the technology. They wanted to understand what stage we have reached till now in our research, and the next stage is going to be the mass scale adoption, because at the end they have to adopt the technology, because it should be a part of smartphone or a laptop infrastructure. Then only we can scale it to consumers. So since we have done a decent work in our domain, we are not afraid of bigger companies doing something in our space. You asked me a question about standardization.
Right.
So all of us came together. We understood that to scale this technology up to a consumer level, we have to work towards the standardization. So we are in a process of forming up that consortium globally, where we are inviting all the key stakeholders in our industry, even though different telecom operators, companies, chip manufacturers like Qualcomm, Samsung, Apple, who is working on the smartphone front as well. So together we wanted to build up that standard for the technology.
And you think that in a few years, maybe 2 or 3 years, we might actually have usable Li-Fi networks on our smartphones and laptops?
Sure.
Much in the same way we have Wi-Fi?
Yeah, exactly. That's the target.
It's just 2-3 years
Yeah,
away.
it's a few years down the line. It will be there.
But in the meanwhile, you've been working on industrial applications as well. Talk us through some of the interesting use cases within an industrial setup.
One of the areas is aviation industry. So we got an opportunity to work with Airbus Space Lab back in 2016. So we got shortlisted for their accelerator program, and we got the opportunity to explore and understand what we can do within the aviation. And this is one of the areas where the LiFi technology can play an important role, because the radio frequency based systems has a lot of regulations within the aviation sector. So we did a proof of concept for wireless in-flight entertainment systems as well. And apart from that, there are specific use cases for telecom industry where standardization might not be required. For example, countries like us where the internet infrastructure is not good. We are talking about 5G now, and to have that 5G infrastructure, you have to lay down fiber cables everywhere within the country, which is impossible. It's not easy. It's a time-consuming process, and a lot of money is required. So we can actually help in creating a better 4G or a 5G infrastructure.
So for example, you could use street lighting in a city to create this network, right?
To create this network. So the street lamps which we already have in the cities, which is already turning into LEDs, they can communicate to each other and create the backbone of the whole network infrastructure.
Shreyas, coming back to you. So a couple of areas, of course, in the telecom space and Wi-Fi, there are protocols and standardizations that have been set up. I'm assuming, and you can correct me if I'm wrong, in the area of work that you are doing, which is actually using the human body as interface, things become a little more sensitive, correct?
Definitely.
And therefore establishing any sort of protocol or standardizations, I'm assuming, is going to be an uphill task. So talk to us about the landscape around this.
Body array network has been there for some time. So wireless body array network, there are IEEE standards for it already.
Okay.
People are talking about human body communication standards also. It's very recent, and it's not too much different than similar wireless-like signals, but putting it inside your body so that it communicates through the body. And in IEEE, there are some efforts regarding that as well.
Okay.
Our technology, which we built this chip on, is broadband human body communication. So it uses the body as a wire instead of the narrow bandwidth that wireless uses. That would require a standardization efforts, or it could be a proprietary technology by some of the medical device companies. So if it's going into the medical devices, for example, one can think about talking to the pacemaker with a smartwatch, so that you can read of how the pacemaker is doing with your own smartwatch. And so somebody around cannot get that signal. So if we were communicating wirelessly, you sitting here can snoop my signals of my pacemaker talking to my smartwatch. However, if we use the human body communication, the signal stays within my body. There are other applications. For example, you and I can handshake, and a business card can go from my watch to your watch. These kind of a consumer, or for example, a Facebook friend request. Imagine walking into a party. If you turn it on using a software, then whoever you handshake with, you get a LinkedIn or Facebook request from, and then later you can choose to accept or reject.
What about payments?
So for example, I can tap and touch, and that will pay. So I don't have to bring out my smartphone and
scan
put it.
a QR code.
Exactly.
Or type a phone number.
You don't need to.
You don't need to.
Moreover, it can be also made secure because it's going through the body. You can use your own biometrics, like your heart rate, signature, to encrypt it.
Okay.
So it doesn't have to rely on your password, which somebody can steal. It can be encrypted with things which are very specific and unique to you, because it is already using the body form factor.
All right. So you have also attached to the work that you are doing at Purdue a startup.
Right.
So talk to us about that. What is the particular area of work within your startup that you're taking forward in terms of commercializing or building a business around some of this technology that has been developed?
Right, and to that end, maybe I should first show you something.
Yes.
This is the smart chip that, this is a human body communication chip that consumes only 6.3 picojoule per bit. In other words, that's 100x lower than today's wireless technologies around the body. So this is dust size, so it's a millimeter by millimeter. So you can imagine including it as a part of any implantables.
So this would integrate into a wearable. You're not looking to develop a wearable from scratch, right?
No. So
you're looking to integrate this with the Apple Watch or the Samsung?
Yeah, Apple Watch or the Fitbit, this just goes in there and enables this communication. So the Purdue startup brings in two technologies. One, this human body communication, and second is machine learning based dosage for neurostimulation. I'll explain what.
Yes, please break it down in normal English.
I'll break it. I have a problem, I have a disease, I take a drug to fix it, right? There is a new concept called neurostimulation, where if you stimulate your correct nerves with electrical impulse, you can get the same effect as taking the pill. So someday, you would be able to stimulate your spinal cord and not have to take a pill and have the side effects, or something like opiate addiction, which is very prevalent in USA. So if you can imagine the amount of pulses we are applying, evolving as your body is evolving and as the disease is evolving.
And this is learning intelligently.
This is learning intelligently. So there will be multiple sensors like this throughout your body, measuring the effect of these small pulses, maybe in your spinal cord or around your vagus nerve, and seeing how you are responding to these pulses. And based on that, there will be a smart artificial intelligence engine, maybe in your smartwatch, which is getting all the data from your body, understanding how you are behaving, and sending that data back to the neurostimulator. So as you see, there is a lot of data movement around the body, which is where the human body communication comes in. And there is a smart algorithm which is needed to understand or make sense of how your body is reacting, in help with a doctor maybe, which is the exact technology, which is the artificial intelligence part of it. Combining these two Purdue technologies, we have a startup called Drug-Free Therapeutics, or DFTX, which is trying to build these closed-loop neurostimulators. In other words, which will just apply small, tiny impulses that can replace drugs in future.
How far away are we from seeing any of this become a reality?
We think it's maybe 5 years away, not 2 years away. but 5 years away, you might not see it. It would be first
Of course.
deployed in the hospitals and clinical trials.
In a clinical solution, but still 5 years.
Yeah, because we already have 67.
It's not that much time away, actually.
It's not that much time because, like you say, this technology, human body communication, is working.
I know, Deepak, I was reading that some of your work actually is also geared towards the medical healthcare clinical side. So you want to talk us through how LiFi is having an application in that area and any specific work or partnerships that are ongoing right now in that area.
For example, in an MRI room, you cannot utilize a Wi-Fi. You have to turn off your smartphones as well. So because there is an electromagnetic interference which comes into a picture when they're scanning your human body. So in those areas, communication is required because it is generating a lot of data, and so we generally have a wired infrastructure in those places. In ICU also, they prevent not using your smartphones, or you have jammers basically, which jams your smartphone signal, plus Wi-Fi is prohibited. So in those areas, to have that communication, Wi-Fi can play an important role because utilize the
communication between devices,
communication
right?
between the devices, yes, correctly. So communication between the devices, even with your smartphone, we can have the communication through light, because we utilize the very generic light. Whichever we are utilizing it for illumination, the same light is sending data as well.
All right. Shreyas, I gave Deepak the opportunity to ask you a question, so I'm going to ask you to reciprocate.
So you said that you can go up to gigabits. Have you compared the energy that is required for wireless versus LiFi?
Actually, if we remove the illumination part from LiFi, if we just utilizing it for data communication, then the energy consumption is way lower than whatever we are achieving in the radio frequency spectrum. And I'll give you another perspective. So if you look at it, if we are utilizing it for illumination, we can actually are not adding up any extra power for the communication. So we are actually saving more energy in that space as well. So the combination of illumination and communication, we are not adding up any extra power.
All right. I've had the most fascinating conversation, I think. At one point, I even had goosebumps. But thanks a lot for talking with us. And I'm, 5-6 years away from something like this. Becoming a part of our lives is actually quite telling. It tells us how far we've progressed and how much further we can go. So thanks a lot for talking to us.
Thank you for hosting us.
Thank you. Let's move on to our next innovator, Manan Suri, professor at IIT Delhi, who has again taken inspiration from the function and architecture of the human brain to build smarter and more energy-efficient computation hardware.
I extensively worked on, what we call as memory technology or storage devices. Let's say the devices that go in your pen drives or in any of your storage media.
Okay.
So I took up those devices and asked myself, how can I expand the intelligence of these nano devices? They're just storing, they're doing a dumb 1 and 0 storage. Can we ask them to compute? Can we do something at the nano scale or at the level of the nanophysics that they start computing apart from storing? Once that is validated, we go to the level of circuits. We pick up a handful of devices, we pick up some existing transistors, we build functional circuits. The next level of abstraction is architecture. So when we have the devices and circuits, then we can put together functional architectures. Then we move toward printed circuit boards. Then we move towards something, something of the sort of a pseudo firmware. And that's when the end user begins to see a complete system, complete hardware system.
And this is exactly what this deep R&D group at IIT Delhi is now moving from. Prototyping to the market with their startup Siren, which is trying to address real-world applications of their research in domains of security, healthcare, and analytics.
In spite of the fact that it's so young, we still have 3 actual industrial clients or users. One of the applications that I would like to call it a POC application, proof of concept application, that we have built is face recognition, ultra-fast real-time face recognition, which is extremely robust and low power.
So how is this different from, say, the face recognition that our smartphones allow us now?
The first point of difference is that, it's more secure because it doesn't need the cloud. So it does edge computation. The next thing is our more performance metrics such as low power or more faster decision time.
On
Yes,
what else are you
yes.
working on at Siren?
Well, we are also looking into some cyber security applications. So data security is a very prominent issue as we are getting more and more digital. It's very important to ensure that the integrity or the sanctity of the data is ensured. So we are trying to use some of those concepts, neuromorphic concepts, for data security.
All right. Thanks a lot, Manan, for
Thank
joining
you.
us.
It's a pleasure to
speaking
meet you.
with you.
Yeah.
Thank you.
Thank you.
Celebrating 16 years of Young Turks.